Today, we're just going to look at how we're going to define what project success is, and we'll look at what I think is the main objective of doing the risk analysis. We've got a few more slides than I normally do, but we will jump into the software later on in the webinar, just to give you a quick demo of some of the concepts that we're discussing here. This webinar is really looking at, I would say, novice to intermediate level people. So it's not going to be too advanced, but really just go over main concepts that we would like to see people doing when they are trying to understand why they should go through this process. So the first thing we want to do is a little bit of housekeeping, we call it. So you should see up on the top right-hand corner that the pane that we can see up here. I always suggest that you use the mic and speakers. The sound tends to be better. If you do have any questions, there is a questions pane, and you can ask them in there. We won't, unless they're a technical issue. You can't hear me. There's something wrong with the screen, something like that. We're probably not going to look at it until at the end, and then we'll have a question and answer. And if I do have any questions come in at that time, we'll take a look at them and answer them in the order that they came in. So with that, let's get going. So I do like this saying, because it really describes what happens when we actually get in. We have a nice plan, and then we actually get into the actual project execution. I think this is a 19th century Prussian general, and probably seen it before. So let's first define what project success is. It's on time, within budget, and value delivered. So that's what I'm just going to say, for the purposes of discussion today. This is what we're going to be looking at. Value delivered can be many different things. Have you gotten all the, all the entire scope? Is everyone happy? Those sorts of things. So it can be a bit ephemeral, but this is really what we're talking about when we talk about project success. We're meeting those objectives. And to do that, we need that high quality plan. So that brings up another question. What is a high quality plan? Well, it has an updatable schedule. So one of the things when we actually do risk analysis, we're going to be discussing quantitative risk analysis. You do have to have a high quality schedule. That means it's updatable. That means if you change the duration on a single item task, it will affect all of its successors. So it has to. So that means not a lot of constraints on it. It has to be able to free flow. It's like a big accordion. As you put pressure on one thing, it will expand or contract depending on how those activities, the state of those activities. Well-defined cost structure, and that can be fixed cost or it can be generated from resources. So we'll sort of roll resources in that as well. And a well-defined scope. What are you going to be actually delivering? And I would add one additional point to this. I think it has to be robust. And what does robust mean? Well, robust means that it can withstand the impacts of an uncertain future. And I just have a couple of examples here. There's the Mars lander that came in, and there's a picture of, I think it's a SEAL team. And both of these are two examples of where projects or people are able to deliver in the face of very high risk environments. And one of the reasons why they're able to do that is by the time they actually get into project execution, they've actually run their project many, many, many times, and they've seen all the conditions that could occur. They've identified the risks, and they've made some adjustments to take care of that. They've tried to eliminate risks as much as possible or minimize them. And once they've run it many, many times, and then they get to the point where they've got the project plan as good as possible, and then they have to account for those. They put in, I call it a buffers, contingency for those things that they can't control. And by doing this, by running and rehearsing and simulating, which we'll come to, their plans, given all the predicted conditions that they'll have, they're able to deliver generally in face of really, really extreme odds. So they have a pretty high success rate when they're running these things. And when you look at what they're doing, it's quite amazing that when I look at some of the space programs, all of the intricate orchestration of these project plans is pretty amazing. And they do it because they've actually have rehearsed it. They've many times they've simulated it. So in terms of projects, when we're looking at project risk analysis, when we say the impacts of uncertain future, we're talking about risk events. So these are discrete risks that have a probability and impact. Now the thing about those, you might call them discrete risks, but they also are manageable generally. That means we can do something about them because they have probability. So we could put in some risk burn down activities or make other things. We could transfer it. It might be that you might have to avoid them altogether. So you have to do some trade-offs in the scope. But we can manage, they're manageable. We've identified them and we can manage them. The second thing is uncertainties and estimates. Now, we have our estimates, and really when we look at it, we call them, sometimes it's called the most likely. Or if you ask someone how long it will take them to do a particular task, they'll say probably will take me, it will most likely take me. And those phrases tell us that it's probabilistic. So they give an estimate based on their historical data, their own experiences, and expert opinion. But again, it is the most likely or the probably finish on. So that tells us that it could finish earlier and it could finish later. And especially in schedules, the ability to finish earlier is constrained because we can't reduce the time it takes to do an activity down to zero unless you actually eliminate it. Whereas on the other side, it could go on for quite a ways. So we end up having these right skewed estimates, distributions of how long an activity could actually take. So from my standpoint, what is a robot? It takes into account all of these things, and we look at it, and we're starting to manage that and then account for these. So how do we create a robust plan? Once we've got I should have had a point for this, but once we've got our deterministic plan in place, we have to modify it to turn it into a probabilistic plan that models predicted risks and variances. And so for that, we'll be looking at historical data, expert opinion, and the other thing is actually looking at, say, what's new or novel about this particular project that might introduce new risks or new uncertainties. And we're going to run a simulation on this, so that we're talking Monte Carlo simulation. And that simulation is going to give us a performance. How well did we perform against what we're hoping to do? So we check the performance, and those are, we'll look at particular charts that tell us how likely it is we're going to finish on time and budget. And then we're going to optimize. So what the results of that simulation give us an idea that targets on where we can best optimize our project plan. And then we're just going to, you can iterate until you get to the point where you've optimized it as much as possible. And obviously when we're looking at this, this type of on a large, long project, you might be running these type of analysis. Once you get under project execution, as you go into different stage gates of your project, you could be running additional analysis just to make sure that you're on top of things. So if we're looking at it and we run a simulation, we've got this pre-optimized plan, and what we can see on this particular one, you see my cursor here, this is our deterministic. So it's just from our software risky project. There might be different views that you'll see in other software. But this is telling us this is what our current schedule has. And if I look at where it crosses the cumulative probability, the S curve, it looks to be around, maybe 5% chance that you're going to meet that, which is pretty common when we first run an analysis on a schedule. And we do have a really bumpy curve here because we have risk events and uncertainties on this. So this is probably our uncertainties that we have here, and these are bumps that we're seeing here. Different curves caused by risk events. And we can see a high confidence level. So P80 is on our cost. And so that what it's just saying, if we want to have a 8 out of 10 times that we can deliver it, we have a certainty that we'll be able to deliver it at 18,700,000, 8 out of 10 times, which is considered a high confidence level. And the P80, or whatever that risk tolerance level is for your thing, is going to be a target in terms of we want to get our contractual dates to be around as we go forward. If you're doing a bid, that you'll get that at P80 or P70 if you're more, or if you're very, very conservative, you might want to have that up at P90. It really, how you set this level, really about what is your risk-taking tolerance within your organization. So we look at the current plan, and there's that high. So now we're looking at optimize, and what's happened is we have that current plan. You can see that now there's most of the risks have been removed from here, so we don't see that really, really bumpy thing. And we've moved that P80. So even though on this chart it still looks to be quite old, we've moved it by quite a bit. So now we've eliminated most of the risk and uncertainty in the analysis. So we have a plan. It's still only about 20%, but the reality is to get from 20% confidence to 80% confidence level, it's $200,000, which is would be pretty impressive actually. And so we've optimized it. Well, how we've optimized it, if you looked at it, we haven't really moved the deterministic all that much, but we haven't done all that much yet. But we've pushed P80 to the right by managing our risks. So we've optimized that way. And so once we've done all of the optimization that we can do, there is still a gap between our deterministic and that P80 that we can't close. We would call that residual risk, or it's unmanageable risk. And so what we have to do is create a risk-adjusted contingency or schedule margin. And it's based on the difference between our deterministic and what P80 is. And what that margin does is it builds out, and we'll put out our bids, or our estimates will be based on the P80, but we'll have put in a risk-adjusted, not just 10% or whatever is the sort of offhand, but it'll be based on the actual project amount of risk that's still in the project. And we'll put that at 80% or whatever risk tolerance level that your organization has. And that will give us that buffer that we'll be able to deliver on time. So that gives us a much more robust project schedule or project plan, because we've managed the risks, we've minimized them as much as possible. And for those that we can't minimize, we're going to account for it. So just quickly, this might, if you've seen the video that we had a quick video on this. It's really just, we have a project plan that has duration, fixed costs, and resources, or it could be just duration, or you could just do it with costs as well. But for this one, we can, for duration, fixed costs are what we call time independent, and resources give us time dependent costs. And we get a risk model, and we assign those risks to to activities with probability and impact. And then once we've done that, we also can assign the statistical distribution for uncertainties. And the reason for that is, like I mentioned earlier, it's there, even though we have a plan on one duration, they could finish early and they could finish later. And we want to account for that, because that's generally, we're going to account for unmanageable risks where the project execution just does not unfold directly on those estimates. They could finish earlier, and they can finish later, and they could finish much later. And so we add these uncertainties to each activity as part of the risk model. We run that Monte Carlo simulation. You can set it to maybe 1,000 iterations, and you'll get unless you have some very black swan risk events that are only occurring once every 100 or 200, they have a very small chance of occurring. You run 1,000 iterations and you'll get the output. And so what we would do at that time, we create the risk model, we look at the performance, and we can see here we have a 4% chance that we're going to meet a certain deadline. We're going to start to optimize. So the step one is that we're going to manage the critical risks. Hopefully, whatever you're using, if you're using risky project, it will sort them based on score. So we'll know which ones we get the most benefit from addressing first. That's really the goal of this, is like, what are our critical risks? Those are the ones that are going to have the highest priority for us to be able to manage. And then we could put a plan in around there. So this is just a quick illustration of what a mitigation plan might look like. And then we're going to identify crucial activities. And these are the activities that have the most potential. So if you're familiar with tornado diagrams or sensitivity analysis, this is a typical one you would see. And this is looking at the task costs, how they are impacting the overall project costs. And we can see it ranks them again based on their impacts. We can see that this drilling task and the gamma ray tests are, again, these will be the activities that we'll look most closely at in terms of where we can optimize to bring in that variance. So we're trying to make sure that there's less uncertainty about them. Could be in the way that we have project execution, or just other factors that might be in there, but we'll look at those first. One of the things that I do like one I prefer, especially if we're looking at cost and schedule, is that crucial tasks. And crucial tasks is the probabilistic or the Monte Carlo version of critical path. In that, what it does is during a Monte Carlo simulation, you can have multiple critical paths. Near critical activities can become critical based on risks or variances during project execution. And so that gives us a better idea of where we should be focusing. And what the crucial task does is it visualizes this on a Gantt chart, and we can see, based on the sensitivity analysis, where these tasks lie on the schedule, and it gives us a quick way to generate a report and where we should be looking the schedule to be able to optimize and be able to optimize and get the most bang for our buck in terms of how we're going to manage the schedule. And then, as always, we can do a continuous optimization. Just brought that same little graphic back. So once you actually get into project execution, is that we should still be thinking about once we have actuals into the system, how are those going to impact, looking out for new risks that might have occurred, and maybe even if you have a change in scope that you might have to run these simulations again. Finally, what we'll look at is that once we've done that optimization, we can account for that residual risk. This is just actually a quick view that we have in our system. It's a report. It's called the simulation reports, and it can be set up. And you can see that we have the base duration and high duration and total cost, and it gives us what the deterministic schedule is and what the margin is on this. And we can start to develop margin and cost contingency at various levels, and it provides a quick report that shows the difference between them. We don't actually calculate those automatically. Might be a nice feature to have in the future, but we can export this out to Excel. And if you wanted to, you could export the low and high durations out to those high durations to Microsoft Project as well, or as an XML file. So what we've done is we've optimized this. The point is we go through, run this, and the Monte Carlo simulations is basically allowing you to practice doing those rehearsals almost of an automated way to run it through everything you think could possibly happen, all the conditions you might meet, and then manage those down to as much as possible. And then finally, the final step is that we have to put in that risk-adjusted schedule and margin. So at this point, I'm just going to give you a quick view of how we would do this in Risky Project. So if you're new to the software, we have a schedule, and we have an integrated risk register, and then we have analysis and tracking. And so on the schedule side, one of the first things that what I did talk about is, let me just go to the project view, is we want to run this schedule diagnostics to make sure that we have a updatable schedule, so we don't want too many constraints. And this is that DCMA 14-point analysis. It's fairly simple to do. This is a sample that we include with the download because it has some good examples of how to assign risks and uncertainties to a system, the sort of analysis you can get out of there. It runs out, and we can see we've got a few hard constraints. That might be because we have a fixed date on there when it starts, but it's not so bad. And this allows us to quickly go through and see what our particular activity missing logic is. We the beginning and the start and end of some activities if they don't have predecessor or successor. You can check those out, but we're not in too bad a shape here. We'll be able to run a valid schedule risk analysis on it. And the second thing is we have our risks and we have a risk register. Now, right now I have them all closed because I don't want to run the simulation on it. Actually, let's go back. We'll look at the calculation. So just so you know, we're going to run 2,000. It's a small project, so we're just going to run 2,000 iterations on this. And we've got, when we look at the high result, it's going to be P80. Now, let me just go back to that. I'm just going to switch this so it doesn't run that simulation right away. And so what we'll do is we will go back to the risks. And I'm just going to enable all these risks. And that gives us, so we haven't added uncertainties to it. And there is some debate about whether you would want to run the risk, when you first run this, whether you want to have the risk uncertainties with it, or you just want to run risks against it, do the first planning, and then run the uncertainties as you have maybe a more detailed schedule. But what you can see here is that it ranks the risk based on the score. If we wanted to see how they've been assigned to the schedule, this is the risk assignment view. So we have these risks, and what it does is it's telling us which activity they are assigned to tasks, which activities, what the chances they will occur, and what the outcomes are going to be. So outcomes are the impacts, and these are all relative delays. So it's a fairly simple one. They can have all sorts of different, if you wanted to, for schedule risk analysis, there's fixed delay, restart task, relative delay, end task, cancel task, and all of these impacts that can be assigned to risks. And we just have these on a fixed delay. And so when we go into there, we can actually look, and we said we can put in a mitigation plan. This one does have a mitigation plan in here. That doesn't look particularly promising. I'll put that down. After we've done all that work, we've brought it down. We can see the pre and post mitigation probability. Put the impacts down, just to give us a better idea about how we can shift that around. So we brought it from a very critical risk down to down here. Maybe that's all we can do. So all the rest of that risk that we have in that system, we're going to have to account for it. That'll become part of that residual risk. And we have the cost of that. And that, if we're looking at that, that all ends up in here. Here's the potential loss. And then we have a probability, then we have an expected loss. And I'm going to say this, and it gives us the little cost, total cost of risk versus the cost of mitigation with mitigation, and it tells us what the sort of savings that we'll get out of this. So not a whole bunch of savings, but it would make sense that if we put into account these, if we put in these plans, we're going to save some money, so we'll put those in place. Now, if I've done that, what I would do is, I'm not going to be, once we run the next analysis, we would we would change the probabilities. I'm not going to do this right now, but you could change those to reflect the changes, the expected changes, if those plans come to fruition. And the next thing is we're going to add uncertainty to the risk. And so there's a couple ways you can do it. I'll use the uncertainty bands, and they are color coded here, and we can calculate coefficients based on that. So I'm just going to, for the sake of brevity here, I'm just going to give them all a high level of uncertainty. And these levels and coefficients that you can use really should be based on historical data that you have about if you have similar activities. New product development tends to have much higher R&D, will have much higher uncertainty into it, obviously, than a sort of a standard, standard construction project, where probably the risk events where you might have problems due to regulatory paperwork, procurement, those sorts of things, tend to have can have a much higher impact. So I'm just going to give that. You can see that they have, gives us this red view, and it's recalculated that. So when we run those simulations, we're going to go again, and we can start to look at the project summary. And of course, because I have the display down so low, we can't see it. So what I'll do is I will look at the project summary this way, and we can start to see what our pre and post mitigated, what our original, we haven't done really any mitigation. And we can see on this one, we have one really big risk event that's occurring. This is our uncertainty that's pushed it over. And again, as I said, when we first run this analysis, you'll see you have a lot of times we will have this type of outcome. It looks very scary. The job now is to manage and optimize as much as possible so we can push this P80 closer to our plan. And it might mean that we actually end up having our plan is actually going to go this way as well, due to the costs, the trade-offs that we're going to have to do. And it might be that you change it to say this is just not realistic, so we're going to relook at it, and it's going to end up here. But we want to move these as close as possible that we can get, and at that point, then we're going to account for this risk. And how much is that? Then the difference between our deterministic, our current plan, and the results on this one, our P80, is going to be the simulation results. Is going to be the contingency and margin. One of the things that I'd like to do once we've done this analysis is to go to, and I set up this, if you go to the reports, these don't get used too often anymore, but I do like this because I can actually go in and I can create this and say, what is this cost? So this is the base duration of the schedule. It's 452 days. This is our high. You can see that. You can pull that down. It says high result P90 or max. It's not. It's actually P80 because I set that in the options, which I showed a little bit earlier. And we've done the same thing with cost, and we can see the difference between those. And so that allows us, using this type of analysis, if we wanted to, I'm just going to actually, let me go to and outline, and we'll go to level 2. And we can look at, and we can start to pull out what sort of, based on our analysis and our optimization where we're at, we can start to get out the values that we're going to have that risk adjusted contingency and margin. So we have this internal schedule that our target that we're going for, but once we've added that risk adjusted margin, and we could do this with finish dates as well. And this is going to be the cost of the projected project that we can deliver at with a high confidence level. So that's the end of the webinar. We run about the length we normally do. It is being recorded and will be posted on our website within the next 72 hours. If you do have any questions, feel free to ask them now. If you don't, and you would like to have an offline discussion about any of the ideas or processes that were brought up in this webinar, please feel free to contact me at Intaver Institute. And we'd be happy to have that discussion.